Hello and good afternoon, everyone. Welcome to our session on powering advanced search using Solr streaming expressions. This session will be presented by myself. I'm Prem Prakash, a technical lead at Fitch Solutions, working on search platform. I will also be joined by my colleague, Wei-Ling Su. Wei-Ling is a senior developer with Fitch Solutions, and she is our in-house Solr and Fusion expert. We will start with a brief introduction to our organization. Fitch Solutions is part of Fitch Group. We offer solutions into credit and macro intelligence, helping clients to manage their counterparty risk. We provide insights and expertise into credit markets and offer various solutions through our flagship product called Fitch Connect, which helps our client make more informed decisions. If you want to know more about Fitch Solutions, please visit our site at www.fitchsolutions.com. If you wish to explore the products and solutions provided by Fitch Solutions, you can self-register yourself at login.fitchconnect.com/register. Moving on to our agenda of the session today, we'll talk about the requirements and the problem statements which made us to move towards using streaming expressions. We'll then take you through various solution approaches that we evaluated along the way. Next, we'll talk about the streaming expressions and the functions that are available there. We will then walk you through the queries and results. We'll give you a short demo on how we have implemented streaming expressions on our end. Next, we will take you through some pagination customizations that we had to do in order to meet our requirements. We'll also give you a glimpse into certain performance optimizations that we did. And finally, we'll take your questions. So this is how our search page looks like. On the top, we have select data items. We also have various filter categories such as sector, geography, financials, and credit. Sector, geography, and credit offers selectable filters, whereas for financials, we offer numeric range filters as well. Once the filters are applied, we get the results in the Manage Results section. So taking a closer look at the filter options available to us, we have entity filters where we can perform a keyword search. We can search for an entity by its name and apply that as a filter. We also have the option to filter the entities by regions and a particular market sector. With the ratings filter, we can multi-select various rating options. We also have sub-filters within the ratings to apply rating actions, rating watches, and rating outlook on top of the ratings filter. Coming to the financial filter options, once we select a financial field, we get an option to select a range filter in terms of above, below, and between, and apply the financial filter by providing the values in the text box here. So these are the options that we are giving to our users to filter the data by. Now if we look at the data structure here, our data is stored into three different collections. One is the entity data, another for the ratings, and the third one is for the financials. If you look here, the entity and ratings data is joined by the entity ID, and all the three collections are joined by the agent ID. Now our requirement is to join the data from these three collections and perform a keyword search on top of it, apply a text filter, and apply numeric range filters for the financial data. And we also want the ability to retrieve the historical data as well. So this is a closer look at how the data looks like. If you'll see, the entity ratings and financial data is all joined by the agent ID. The entity ID is used interchangeably here with the agent ID in the financial collection. Now the entity and ratings collection, if you'll see, is joined by the entity ID. Now our requirement is to pull all the data available here in these three collections by a single query. Okay, so how do we solve this problem? So before we solve the problem, we also looked into the option of storing all the data into a single collection. However, that was not an option for us given the complexity of the data structure and the nature of the historical data available to us. So what benefit it provides by storing the data into its own collection? The first and foremost, the data structure is quite simple this way and easy to handle. It provides better isolation of the data, and retrieving only a particular data set will be easier due to isolation. We have many other requirements where we need to show only a particular data set on different screens. The data refresh also can be handled quite easily, as different data sets may come from different sources. So overall, we found that the maintainability of the data is much more easier if we store the data into its own collection. So in order to solve our problem, we tried several approaches that support Solr data join. We looked at various options such as Solr join query and subquery. Solr Parallel SQL, Fusion SQL, etc. We did a side-by-side comparison on various parameters listed here. We looked at whether they support joins, which is our basic requirement. Do they have any limit on the number of collections that we can join? So in future, we wanted the ability to join more than 3 collections as well. We also looked at whether we can perform filters on both sides of the join, whether they support keyword search, sorting, grouping, pagination, and whether they allow any customizations to be applied on the functions. So pagination support was one of our key requirements. Pagination is listed here as maybe. We'll come to the pagination implementation with the streaming expressions in our future slides. So based on our analysis, a streaming expression emerged as a clear choice for us, which solved all our problems of retrieving the data from different collections. So what are the benefits of using streaming expressions? It provides powerful stream processing language and has a load of functions to perform different operations. It has a big growing library and a good community support. One such community support was very useful to us. We will cover more about that in our future slides. So talking a little more about the streaming expressions, it provides 3 different types of functions: stream source, stream decorators, and stream evaluators. The stream sources originate streams. The most commonly used function here is search, which performs a query on the Solr collection. Other available functions are tuple, facet, topic, etc. Stream decorators wrap other stream functions or perform operations on a stream. The functions available here are select, sort, top, inner join, etc. Stream evaluators are different than stream sources or stream decorators. Both stream sources and stream decorators return streams of tuples. Tuples are nothing but a row of data retrieved from Solr. Stream evaluators are more like a traditional function that evaluates its parameters and returns a result. Most of the functions here are self-explanatory. For further details, you can refer the reference guides available in the Solr documentation. So with this, I'll hand it over to Wei Ling, who will cover next set of slides and will walk us through a use case on a streaming expression. Thank you.
Thank you, Prim. My name is Wei Ling, a senior search engineer and Fusion admin for Fitch Solutions. I have worked and followed Solr since Solr 1.4. We will walk you through a use case to understand how streaming expression is implemented to support Fitch Solutions' advanced search requirement. For example, one advanced search will look like this. Please find an entity that the name will match bank. His financial total asset in bank is greater or equals to 2.0 million. And rating type is long-term issuer default rating, and his rating value are A-, A+, AA, AA+, and AAA. For output, we would like to sort by entity name in ascending order, offset starting at 0, and page size equal to 25. Let's look at the entity data stored in the core collection. We use search function to filter out the matched tuples from core Solr collection. A tuple is a streaming data element that consists of a combination of the raw data of data values and the timestamp. In core collection, we are applying text search on entity name underscore T with the bank. Add filtering condition by specifying content type equal to entity. For sort option, we can apply any sort on any of your return fields. Since our next step is to perform joins, join operation require us to perform both join stream in the same sorting field type and in the same sorting order. You can save one sort function by specifying the same sort field and sort order to prepare for the later join. After that, we use select function to project the fields and or rename the fields. In this case, we want to rename entity ID to be issuer or transaction ID and ID to be group by ID. Qt parameter, by default, it will be using search handler, but it will return paginated output in return. You won't get the total record back. If you want to apply the join to the whole collection data, Qt parameters must set it to equal to export. In our case, we want to perform inner join to find out all the matches ones. In the second collection, we are filtering data out of the financial Solr collection using search function. By applying the range filter on total asset bank greater or equal to 2.0, and also specify other filter criteria in period type equal to annual, latest statement equal to true, statement date equal to last 18 months, and accounting standard equal to USGAPP, and the cross consolidation type equal to consolidated. We then use select function to rename the field to be a more meaningful name. Perform the sorting function on entity ID in ascending order. For rating collections, we use search function to apply the filtering on rating value and specify the rating type equal to Fitch ratings and set rating latest flag to be true. We pick the entity ID as our sorting field and sort in the ascending order. As I talked in the previous slides, we are preparing for the later join condition. Once all the data has been filtering out properly from each collection, we are ready to move to join operation. We are making the inner join by calling inner join between core collection and financials collection with join condition on agent ID. There are several join types to pick. You can choose hash join function too. If the data are small to fit into your memory, it will definitely give you some performance edge over inner join, but we have big data to deal with, can use it. When calling inner join function, you specify the join condition with parameter on equal to certain condition. If both join fields from both sides are the same name, you can just put one single field name there. If not the same, you need to specify it by left field name equal to right field name. Sometimes we need to perform another sort before next join because the join field or the order are not the same. Now, this is our final set of inner join. The data returned from the previous join of the entity and financials is now joined with the rating data. We are applying sort function on top of the inner join between the entity and financial, which is required to enable join this data correctly with rating, because inner join with the rating data are on the entity ID, not on the agent ID we used in the previous join. Here is how our final query looks like. We perform the inner join on entity and financial, and that result is then joined with a rating. In our requirement, we need to perform a reduce operation to group by ID field, because our final result is aligned by group by ID. One entity is going to have many matched ratings and many financial records. Group by it, we knew if we have 0, 1, or many matches. Group by it, we know how many unique entities are matched. Finally, we are applying the pagination using the limit function and skip function to display them in a paginated manner to the client. Now, let's run the above query and take a look at the JSON data returned from all the previous streaming expressions function. On the left panel, it contains unique entity information, although it only picks one of the many of one and display on the left. On the right panel, it's displaying grouped data in an array. You can see that It contains different possible joins with the rating and financial detail there. We are happy that we implemented the streaming expression to produce the output we want, but our client can't display all due to the performance concern. They want to be able to browse the records in a pagination format, but we search all the Solr versions. No such things. What should we do? Go back and re-engineer it? No. We knew Solr is an open source software, and we decided to implement new Solr stream expression to support it. Before we did it, we find one patch for it, but it was for newer Solr 8, not for Solr 7. And stream expression architect had been refactored in Solr 8. So we and migrate the same computing logic to our own Solr version and then integrate back to the Solr. To add new streaming functions, it will be required to extend tuple string abstract class and then to implement expressible interface. ToStream function was added. Skip stream is used to skip first number of tuples. Limit stream was created to limit the total number of records to return. Last, update the string handler class to load them into stream factory. So the stream factory object will load them along with other stream expression function at startup. To make sure our version is compatible, we downloaded the same version we use in our server and make changes and updates to it and recompile, redeploy to the Solr server. We are using Solr through LucidWorks Fusion software. Solr are embedded inside Fusion software. We have to update the Fusion Solr libraries so our Fusion can see the new streaming expression function. Fusion has repackaged Solr, so there are several places to update. Before you update them, backup your old one so you can roll back to the previous status in case you mess up. After testing one Solr instance with successful, rolling update the rest of Solr instance in your Solr cluster. The building streaming expression phase is done. Next, I will hand over to Prim. He will share you how we toggle down the next phase of project performance.
Thank you, Welling. So talking about performance optimizations, we were very excited to use streaming expressions. It solved all our problems. However, we observed certain slowness in the queries when performing complex joins involving many filters. To improve this, we analyzed the queries and figured out ways to improve the performance. We found the following approaches that helped us. The first thing that we did was we applied appropriate filters to reduce the total amount of data before applying the join. We also limited the fields to select from both join collections. We applied the parallel function to do the parallel computing wherever it was applicable. We also went for a hybrid solution between a standard Solr query and streaming expressions when performing complex joins. We will elaborate further on the hybrid approach in our next slides. So now let's take a look at the architecture that we have. Our index data is available in Solr, and we have created pipelines in Fusion to retrieve the data from Solr. Here we have introduced another layer between Fusion and web client called Fusion Query Service. The Fusion Query Service helps construct the streaming expressions for us. The request coming from the client is parsed and converted into a streaming expression query in this layer. The response received from the Solr or Fusion is transformed into a JSON output and returned to the client. This kind of architecture helps us to hide the unnecessary implementation details from the client and also helps us to expose a simple request payload for the clients to query the data. Also, this way the client need not worry about the joins and the technologies used underneath. So these are the benefits this kind of architecture provides to us. So coming back to the hybrid approach, we took a decision based on the user behavior and functionality driven from that. When we load our default page, we show only the entity and default rating information. In those cases, we have seen the queries performed via the pipeline perform better than the join queries. So we route those queries via a normal entity and rating pipeline and process the data in the service layer itself. However, when user applies the advanced filters on the entity, rating, and the financial data, we route those queries through the streaming expression pipeline. This approach gives us a fine balance between querying the simple data versus advanced data using complex joins. So with this, giving it back to Wei Ling, where she will talk about some session takeaways. And we will see you again in the question and answer sessions. Thank you.
Thank you, Prim. When we look back at our past journey with streaming expression implementation, some we did very well, others wish we could do better with other options. These are the takeaways we learned from our experience. If you need to add a customized implementation, use stream expression plugin approach to add internal-only function. Solr stream expression plugin architecture would be a better option, more pluggable. There are previous talk from Greenberg about this. You can search on the YouTube or ask me later in the chat channel. If you plan to share and make a contribution back to the Solr community, you can use our approach, rebuild and redeploy the Solr. Create empty worker collection to run stream expression handler. You can customize for stream expression's performance by creating multiple shards and replica, and it will trigger multiple workers to run the stream expression on empty dataset. Use parallel and parallel list to parallel computing whenever it's possible. For some query, there's no dependency or order restriction. Parallel streaming processing will maximize the computing power. Applying the filter before applying the join operator. Based on our performance testing, the streaming expression computation time is linear correlation to the size of the data. Apply the filter first. You can reduce the total size for later pipeline. Last, build and validate the stream expression step by step, inside out. We found this is very effective in debugging and building query at the first time. And finally, question and answers. If you have any question on any of the topics presented here in this session, please reach out to us through the chat facility provided by the Activate. Thank you for joining the session, and also thanks to the LucyWorks as well to give us the opportunity to present in this conference. In case you need to reach out to us, our email are available under the speaker profiles. Thank you, have a great day ahead, and enjoy the rest of the sessions.